let's talk about the change of base rule. So I'm going to have you write it down and then we'll talk about it. Here's the change of base rule. It says log base b of x equals ln of x over ln of b, or it also equals log of x over log of b. Now, the change of base rule was actually way more useful probably about 10 years ago. A lot of your calculators nowadays will have a log base button that will let you put in log of any base. So let me give you an example. If I told you to calculate log base 3 of 7, most calculators nowadays have a log base button that I could just put the 3 in the base, 7 in, hit enter, get an answer. However, even when I was back in high school, our calculators didn't have a log base button. So instead, we had to use this change of base property so that we could type this answer in to get an answer. So instead of being able to type in log base 3, our calculator didn't have that button. However, our calculators did have ln buttons and log base 10 buttons. So instead, I could type in ln of 7 over ln of 3, and it's the same answer. You can test that out right now. You could type both of these into your calculators, and they'll give you the same decimal. So, or you could also do it with log base 10, log of 7 over log of 3. So like I said, this change of base property used to be a lot more useful, and it still is if you have a calculator that doesn't have that change of base button. If you have a calculator that doesn't have change of base button, this is how you have to type it in because your calculator doesn't have the ability to do that. However, if you do have a calculator that lets you type this in, this you don't need so much. You don't need to remember that. However, there is one kind of 1050 question that I have seen asked on finals where you would be required to remember the change of base formula, and it's example 2. And if you read it through very carefully, you'll see in the instructions why it needs the change of base formula. So example 2 says, convert the expression log base 4 of 5 to base e. So notice, this problem is not asking you to solve for what this is. It's not asking you to plug this into your calculator and get an answer. It's asking you to convert the expression, to rewrite this expression to use base e instead. Well, we know base e is another word for ln. So it's asking you to rewrite this using ln's instead of log base 4's. That is the change of base. So ln of 5 divided by ln of 4, that is the same thing, and that is our answer. We have converted this into base e logarithms. So the wording of that problem is very specific to make sure that you know the change of base, where it's not asking for an answer, it's asking you to rewrite the problem using the change of base formula. So that kind of problem is going to be the most useful to you where you would need change of base. Now, with that, we only have 2 properties left we need to discuss. We have the logarithmic one-to-one property, which is very similar to the exponential one-to-one property. If you remember that from last class, it was if the exponent bases are the same, we can just set the exponents equal to each other. Well, our logarithmic one-to-one property says if the bases of the exponent are the same, bases of the logarithm are the same, then the insides of the logarithm will be equal. So it's kind of like saying if I had log base 3 of x equals log base 3 of 5, then it would be easy to say that x should be 5. If those bases are the same, then you know the inside should be equal. That's your one-to-one property. Then the inverse property, you've probably already used a little bit. The inverse property says that because logarithms and exponentials are inverses, they're opposites, they undo each other. If I have a log base b and an exponent of the same base, they're actually just going to cancel each other out, and I'm just going to be left with the x. So kind of like if I had log base 8 of 8 to the 4th, because the base of the log matches the base of the exponent, they will undo each other because they're opposites, they're inverses, and I'm left with just 4. So that's the inverse property rule. Now, in the next video, we'll actually start to do some problems where we apply these rules and practice them.